Hey guys, today I'm going to teach you how to solve systems of equations by inspection. By the end of this lesson, you'll be able to determine the number of solutions a system of equations has just by looking at it closely. So go ahead and take out your binder, turn to the math section, and let's get ready to take some notes. All right, so today's lesson is actually not going to involve a whole lot of math. Today, it's actually taking a step back and using what we already know about looking at systems of equations to determine the number of solutions without actually having to solve it or graph it. And that's called inspection. So we can determine the number of solutions just by observing and drawing conclusions from the equations. For example, if we know that two equations have the same slope but different y-intercepts, that means the system has no solutions. Again, if the two equations have the same slope but have different y-intercepts, that means they would be parallel lines. They're going in the same direction forever, but they're never ever going to touch. And remember, the solution to a system is where they intersect. So if they have the same slope but different y-intercepts, we could just go ahead and write no solution for the answer, not having to do any math other than that. Now, on the other hand, if the system of equations have the same slope and the same y-intercept, then that means that the system has infinitely many solutions. There's an infinite number of solutions. If the equations have the same y-intercept and the same slope, then they would be the same equation, just maybe written differently. So just by looking at the equations, we can answer whether it has no solution or an infinite number of solutions. Let me show you what I mean here in example number 1. So these are two equations you're looking at that are written in slope-intercept form. That means y equals mx plus b, where that b, and in this case it's the 9 and the negative 9, those are the y-intercepts. Where if you graph these lines, that's the first point on the y-axis. The number next to x is the slope. So in this case, 1.5 is the slope for both of these equations. So look at what we just learned up here. If we know the two systems have the same slope, but different y-intercepts, just like we looked at here, same slope, 1.5, but positive 9 and negative 9 are the y-intercepts, the system would have no solutions. Just by analyzing these two lines and equations and looking at the patterns in them, I figured out my answer to this without having to do any math and solving these out. However, if I were to graph this, it would show me that I have a set of parallel lines, which don't ever intersect, so they can never have a solution. That's why the answer to this question is just no solutions. But I didn't have to do any work for that one. Just by looking at the pattern here, realizing they have the same slope but a different y-intercept, I inspected the equations and solved it out by that. So let's look at another example and see if we can do the next one without having to do any real math. Question 2 is going to involve some logic. So I have two equations. 7 times a number plus 3 times another number equals 10. Below that, I have the same setup. 7x plus 3y equals 30, a different number. So it's the same on the left side in green, but in blue on the right, I have a different number. Is there any number I could put in for x and y that would make this true? Think about it. Press pause and think about it. Press play when you're ready to think about it with me. All right, so in this situation, both of these lines are not written in slope-intercept form. So it's hard to look at these little clues up here and determine whether we know something about the y-intercept or the slope. However, just by looking at this logically, 7x plus 3y equals 7x plus 3y. That means whatever's on the right should equal each other as well. It's an equation. So whatever this side equals needs to be equal to this side. But 10 and 30 are not equal to each other. In fact, there's nothing I could put in for x and y to make this true. It's impossible for 7 times a number plus 3 to have more than one outcome. So how many solutions does the system have? None. This is another example where there would be no solutions possible for this system of equations. Let's check out number 3 and see if we can figure it out without having to do any math. We're given two equations that are both written in slope-intercept form. So I can look for the slope. The slope is the invisible number next to the x. In the top one, it's 1 since there's one x there. And in the bottom one, it's a negative 1 since there's a negative sign next to the x. And there's only one x. So 1 and negative 1 are different numbers. And the y-intercept is different for each of these equations. In the top one, it's the number all by itself plus 1. In the bottom one, it's a negative 1. So it has a different slope and a different y-intercept. If it has a different slope and a different y-intercept, that's just like normal. That's whenever you'd see a one-solution system of equations. In this case, when you get an equation or system of equations that has one solution, this is where you would have to solve it out. You can do this by graphing, and you can graph these two lines using a calculator or by paper, and then you would be able to find a solution where they intersect. You could also use substitution method for this one and set x plus 1 equal to negative x minus 1. After you've set up your equation looking like that, it's actually pretty easy to solve this. You move your x's to one side and you move your numbers to the other side. When you do that and you simplify, you end up with x equals -1. And when you plug that into either one of these equations, -1 plus 1 is 0. So your solution to this system would be -1, 0. So I just want to point out that this one we had to solve because there was one solution. However, looking at the other two, we just found patterns in the equations without having to do any math. We realized these were examples where we had no solutions. Let's look at another one. I have two equations. One of them is written in slope-intercept form, and the other one is not. The second one is written in standard form since x and y are on the same side. Standard form is not really useful to us. So what I want to challenge you to do is that anytime you see an equation written in standard form, you rewrite it into slope-intercept form. Let me show you that now. So when I want to change this equation into slope-intercept form, that's that y equals mx plus b format. The only thing that is by itself on the left side of the equal sign is the y. So the only thing on this equation that should be by itself is the y. So I'm going to go ahead and put like a little circle around the y. So I know that's what I'm solving for. When I draw my line on the equals, I'm not moving only letters to one side and only numbers to the other side. I'm moving everything else, the -8x, the 4, I'm moving all that to the right, and I'm only going to keep the y on the left. So let's go ahead and do that. I need to get rid of everything that's surrounding that. So I need to get rid of this -8x. To get rid of a -8x or a -8x, I'm going to add 8x, and I'm going to do it to both sides. So you can't simplify 2 plus 8x. So I'm just going to have to write that as 2 plus 8x and keep the 4y over here on the left. Remember, my goal is to keep the y by itself. So I need to get rid of that times 4. I'm going to do that by dividing by 4. If I do it to one side, I have to do it to the other side. And I'm actually going to divide the whole expression on the right by 4. So I'm left with y equals 2 divided by 4, which is 1/2, and then 8 divided by 4, which is 2. So I have y equals 1/2 plus 2x. This is the exact same equation as this. This one's just written in slope-intercept form because I have a y equals mx plus b. The top one was written in standard form, and it wasn't really helpful to us because when I have it written in slope-intercept form, I have a y-intercept and a slope. So I'm going to cross out this equation because that's the same thing as y equals 1/2 plus 2x, which I just found. Now when I determine how many solutions the system has, I'm comparing this equation to this equation. And if you look, they have the same slope, the number next to x, and the same y-intercept, 1/2. Since I wrote them in the same format, I can see that since they have the same slope and the same y-intercepts, the system has infinitely many solutions. And that's all I have to write, infinitely many solutions. So today's lesson is all about using little shortcuts, little problem-solving strategies, and looking at these logically. When you're given two equations that are written in different forms, maybe try to convert one of the forms into the other one. And when you do that, you can compare them a lot easier and look for those shortcuts. That way you don't have to graph these or solve by substitution. You can just solve it by looking at it and realize there's an infinite number of solutions to this system. So here's some practice with that skill specifically. We're going to match each equation on the left here with the equation on the right that makes a system with infinitely many solutions. So you're actually looking for the same equation. It might just be written a little bit differently. So take a second. I want you to try all these by yourself. See if you can find their matching partner that is the exact same equation as them, just written differently. And just press play whenever you're ready to check your answers. All right, here's the answers. If I was you, if I was looking at these, what I would do is I would take anything that's written in standard form, aka not y equals, and I would convert it into slope-intercept form, make it y equals. So like this one I just highlighted in yellow, it's not written in slope-intercept form because the y equals is not by itself. So you want to convert it by taking off the 2x and then dividing it by 3. That's going to make it a perfect match with A. Whenever you do these, please make sure that you're also double checking these at first, especially while you're not so used to this, on a graphing calculator or even by substitution if you're feeling good about it. Just because you have so many methods to do systems of equations, please take advantage of them while you're practicing this now. All right, guys, that's it. If you made it to the end of this video, please put in the comments your favorite planet. Today, we learned how to solve systems by inspection. So now you should be able to determine the number of solutions to a system just by inspecting it and looking at it closely, looking for patterns, and maybe rewriting the equations in slope-intercept form to compare. So now you should go ahead and go back to the calendar, complete any other assignments you have left for the day. Let me know if you have any questions. Bye.